All right, today we're going to be going over the Module 2 test review. Okay, let's start with number 1. So it says f of x equals 12 plus 4, x minus 6. What is f of negative 3? So before we can find f of negative 3, there's two ways we can solve this. First, some of you are going to see that there's a set of parentheses here, and we can start by getting rid of that. Or we can just straight away plug in negative 3. So let's try doing it both ways. So first, I'm going to take negative 3, and I'm going to put it anywhere I see x. So I have f of negative 3 equals 12 plus 4 times negative 3 minus 6. I know we follow PEMDAS, so parentheses goes first. Negative 3 minus 6 is negative 9. And then we're going to times that by 4 plus 12. 4 times negative 9 is negative 36. Bring down our 12. 12 minus 36 is negative 24. So f of negative 3 equals negative 24. Now, you could also do this by simplifying. We could start by distributing the 4. We would get 12 plus 4x minus 24. Combine like terms, 12 and negative 24 gets us 4x minus 12. And then we plug in our negative 3. So f of negative 3 minus 12. We get 4 times negative 3 is negative 12 minus 12. Negative 24. So either way you do it, you get f of negative 3 equals negative 24. That means if our input is negative 3, our output will be negative 24. All right, number 2. It says, if f of x equals 3x squared minus 2x plus 3, what is f of negative 2? So same thing, we're plugging in negative 2. So here I'm just going to do it straight away. Anywhere I see an x, I'm going to plug in negative 2. And I'm going to rewrite everything exactly the same besides the x. And this is going to give me f of negative 2. So now we just follow PEMDAS. You could also use your calculators. If you type this in exactly as you see it into your calculator, with nothing missing, every parentheses, every negative, it's going to give you the same exact answer as if we follow PEMDAS. So parentheses, we don't have anything to solve in the parentheses, so we move on to exponents. Negative 2 to the second power, it's like you're doing negative 2 times negative 2, which is going to give us 4. So we have 3 times 4 minus, we know negative 2 times negative 2 is positive 4 plus 3. 3 times 4 is 12. 12 plus 4 plus 3. And then from here, you just add them all together. 12 plus 4 is 16, 17, 18, 19. So f of negative 2 is going to give us 19. All right, number 3. Jeremy has a $12 gift card to use to buy comic books. Each comic book costs $3.25. The function f of x equals 3.25x minus 12 represents the amount of cash required to purchase comic books after using his gift card. Complete the following sentence. Jeremy needs blank blank to buy 8 blank. All right, so the first thing we know is that Jeremy's going to be buying 8 of something. Well, the only thing that the problem is talking about is comic books. So we know he's buying 8 comic books. Now, we want to figure out, this function will tell us after he uses his gift card, after using his gift card, how much cash he needs to buy the rest of his books or all of his books. So we're going to start by rewriting our function, and instead of x, we are going to be plugging in 8 because I know $3.25 is the cost of each comic book, and I know we're buying 8. Equals 3.25. Instead of x, we're plugging in 8 minus 12. All right, and from here, we're just solving. So we start by doing 3.25 times x, which is going to give us 26 minus 12. And 26 minus 12 equals 14. So that means in order for Jeremy to buy his 8 comic books, he's going to need $14 after he uses his $12 gift card. Okay, so now let's see if we can finish this sentence. Jeremy needs $14 2x8 comic books. So our 14, our dollars, and our comic books. Awesome. All right, number 4. For number 4, it says complete the following sentence. All right, so we're given 3 graphs. So let's start with this last one. I see this one's easy. We can go ahead and get rid of this one first. So function blank has a y-intercept of 0, 2, or 0. Well, if I look at the y, I know this is my y line. I'm looking for which graph intercepts at 2. Well, I know that's going to be graph C. So that one was easy. All right, the function blank, let's look at the second one now. Function blank is increasing for positive values. X is greater than 0. So I'm going to go when my x's are greater than 0, when these are bigger, which of my graphs are increasing? Well, I know that if I read my graph from left to right, I know this blue line is going up. So I know this is going to be graph A. The function blank is positive for negative values x is less than. So when my x's are less than, which of my graphs is positive or has positive y values? Well, I know B, these are all positive values. This is 1, 2, 3, 4, so forth. So that's going to be graph B. And it's always good to start with what you know. This last one was the easiest one since we know y-intercepts. So that was the easiest one to start with. All right, number 5. Josue was given the following linear functions to compare their key features. The exercise is asking Josue about some of the features of the linear function just when the values of x is between -1 and 4. All right, so select the function that is increasing and decreasing. So the best bet for this one is going to be for us to roughly sketch each one. So this is going to be my t of x. This is going to be p of x. All right, so let's say I plug in, well, let's look at the values we're looking at here. So I'm going to plug in -1. I know -2 times -1 is +2, plus 2 is 4. So I know -1, comma 4 is a point. So -1, up 1, 2, 3, 4, right here. All right, if I plug in 0, if this becomes 0, I know -2 times 0 is 0, plus 2 is going to be 2. So it's going to be 0, 1, 2. So just based on that, I can kind of predict this is what my graph is going to look like. All right, now let's try p of x. If I plug in -1, -1 times 3 is -3, plus 3 is 0. So I know that's going to be -1, 0. Let's try plugging in 1. 1 times 3 is 3. Oh, let's try plugging in 0, actually. 3 times 0 is 0, plus 3 is 3. So I'm going to do 0, 1, 2, 3. So our graphs are going to look something like this. Okay, if I'm reading my graphs from left to right, I know this graph is decreasing and has a y-intercept of 2. This graph is increasing and it has a y-intercept of 3. So it says function t of x is decreasing and function p of x is increasing. Well, we know that's true. Function t of x is increasing. No, because if we put our little person on the mountain, he's going down the mountain. So I know it's not going to be b. I know it's going to be a. Both t of x and p of x are increasing. No, we know p of x or t of x is decreasing. The y-intercept of function t of x is greater than the y-intercept of function p of x. Well, 3 is bigger than 2, so that's not going to be true. And the last one, the y-intercept of p of x is greater than the y-intercept of t of x. Well, that is true. Awesome. All right. It says the table shows the number of visitors to 4 different websites in the first 6 months of 2023. Of 3 different websites in the first 6 months of 2023. All right. And we are looking, if the pattern continues, which website will have the highest number of visitors in February of 2024. So first, let's see if we can try and figure out a pattern. So from 200 to 500 to 700, we are going up by 500. From 700 to 1200, we are going up by another 500. From 1200 to 1700, another 500. And we continue to go up by 500. Okay. From 200 to 400, we're going up by 200. From 400 to 800, we're going up by 400. From 800 to 1400, we are going up by 600. From 1800 to 2200, we are going up by 800. And from 2200 to 3200, we are going up 1000. All right. And then finally, 50 to 100, we're going up 50. 100 to 200, we're going up 100. 200 to 400, 200, 400 to 800, 400, 800 to 1600, 800. All right, so if we were to continue, let's say we wanted to try July. So if we go up another 500, we're at 3,200. And here it seems we're going up so from 200 to 400 we went up 200, from 400 to 600 we went up another 200. So it seems like a double pattern. So from 1,000 we're going to be going up 1,200. So that would be 4,400. And here we seem to be doubling. So from 50 to 100, we went times 2, times 2, times 2, times 2, times 2. So here, 1,600 times 2 is 3,200. All right, so you would simply be following the pattern over and over again for each one. So we have July. Now we're going to August. All right, we'd be going up another 500 for website A, which is going to give us 3,700. We went up 1,200 here, so now we're going to be going up 1,400, which is going to give us 58. And here we're going to be doubling, which is going to give us 6,400. So we could continue the pattern, but we can already tell which one's going to be. Just by doing the next 2 months, we already know that website C is going to beat. Why? Because website C is doubling every single time, and that is actually an exponential function. And I went over in class that exponential functions will always beat anything that's adding or subtracting, no matter how high the pattern looks. So we know website C will have the highest number. And you could keep going. We could do August, September, and then October, and then all the way down to February of 2024. But we should remember, if we are multiplying, that's always going to increase at a faster rate than if we're just adding and subtracting. All right, which is the graph that corresponds to an increasing linear function with solution x equals 2? All right, so I'm looking for, now solution is another word for root or x-intercept or 0. So all of these words mean the same thing. They're looking for the x-intercept. So I'm looking at which of my graphs has an x-intercept of 2. Now remember, your x is your horizontal line. So we want to know which of these graphs is touching the horizontal line at 2. If we mark here, okay, that's at 2. This is at -2, so that doesn't work. This is also at 2. And this is at -2. Okay, so we're left with A or C. Now it says an increasing linear function. So I'm going to put my person on the mountain. I'm going to see which one's going to be going up the mountain, and that would be A. All right, number 8. Cameron needs to find a function in the following list with these key features. So it has an x-intercept or 0 of the function is 3 or at 3, 0, and the y-intercept of the function is -9 or at 0, 9. So I'm going to be looking for the one that gives me a x-intercept of 0 and a y-intercept of -9, of 3, sorry, an x-intercept of 3 and a y-intercept of -9. So we can start, easiest way is to start plugging in for each of the functions. So let's start with C. So if I plug in, let's start with the x-intercept. If I plug in 0 for y, I should get 3 when I solve. So I'm going to plug in 0 for y. Well, let's try using the x-intercept, or the y-intercept. Plugging in 0 for x tends to be easier. So -9 times 0 minus 3. -9 times 0 is 0. 0 minus 3 is -3. It should be -9, so I know C is not my answer. Okay, let's try B. If I plug in 0 for x, 9 times 0 minus 3. Well, I know 9 times 0 is 0. Minus 3. Nope, not it. Okay, let's try A. If I plug in 0 for x, 0 times 0, 3 times 0 is 0, -9. Okay, A could work. And let's try D. -3 times 0. -3 times 0 is 0. Okay. D also works. All right, so now let's plug in 0 for y. See what we get. Let's start with A. 0 equals 3x minus 9. And remember, this is always x and this is always y. And y is also the same thing as f of x. So that's why we can plug it in for f of x. Okay, plus 9 on both sides. We get 0 plus 9 is 9 equals 3x divided by 3. We get x equals 3. So we know A is our solution. And even if we just wanted to try for D, let's say we wanted to check D, I would do 0 equals -3x minus 9. Follow the same steps. Plus 9 on both sides. We would get 9 equals -3x divided by -3. And we would get x equals -3. And I'm looking for x equals +3. So that's why D would not work. All right, number 9. Which of the following tables does not correspond to a linear function? So remember, we said linears have to have a repeating pattern of either addition or subtraction. They cannot have multiplication. So I'm looking for which of these patterns does not repeat using addition and subtraction. Well, I know from 5 to 10, I have 5. 10 to 15, 5. 15 to 25. 20 to 25, 5. Okay, that one doesn't work because I'm looking for the one that does not. 8 to 11 is 3. 11 to 14 is 3. 14 to 17, 3. 17 to 23. Not going to work. 33 to 45 is going to be 12. 45 to 57 is 12. 57 to 69 is 12. 69 to 81 is 12. So that is also not going to work. So that's just going to leave letter D. Now, let's just double check. 3 to 6 is 3. 6 to 12 is 6. 12 to 24 is 12. 24 to 48 is 24. So this one's pattern does not repeat with addition and subtraction. If we look closely, it is actually multiplying by 2. Awesome. And that is our last problem for the Module 2 test review.